Our previous discussion thought about whether we could make causal claims from observational data. And essentially, I proposed to you that that is very difficult because we need variation in the variable we care about to be as good as random. And then I suggested that there could be an idea of running some kind of experiment or finding some variation in the world called a natural or quasi experiment that looked like allocation into some kind of intervention was random, would help us make causal claims and particularly estimate the size of an effect. Now I want to think about how we could do that. And the approach that we're ultimately going to take is called difference in differences. So what is difference in differences? We're trying to answer a question. What is the effect of some marketing intervention, for example, or a policy change, if government policy might be relevant to a marketing analyst? What is the effect of some intervention on people who were affected by it? Call the intervention a treatment, just for simplicity and to help fix ideas. Treatment is going to take one of two values. It's going to take the value of 1 if an observation is ever affected by the treatment, and 0 if an observation, so a person, is never affected by a treatment. The observations, so the people or the companies or the provinces that we're following, are assumed to be getting this treatment at random. So we're not systematically thinking about that guy because of something getting a treatment. It's going to be like randomly allocating people. We're going to be interested in whether this treatment affects an outcome variable we're interested in. It might be sales, it might be revenue, some other marketing performance indicator. So we're interested in tracing out the effect of a treatment on an outcome. How might we do it? Is the question that we want to answer. So how can we quantify this effect and think about whether it's causal? The first way you could think about doing this is say, well, I have data on observations. So think about it as individuals, right? Or firms who were treated, who were given this intervention. And we have observations on them before they got the treatment and after. We could try and take the average value across the individuals who were treated after they were treated and subtract away subtract away their average outcome value before they were treated. So kind of after minus before for people who are randomly thrown in to this treatment. And we could think about whether that is an estimate of the treatment effect. This is not going to work. The reason it's not going to work is because essentially time might play a role. The outcome variable might move around over time for reasons not just because of the treatment. For example, revenue might be generally increasing for firms over time. So if you then just compare average revenue for firms in the after period and average revenue for firms in the before period, then there's going to be two effects. In the after period, they were treated, they got the intervention. So part of that change is the effect of the intervention. The other reason there's a difference between before and after in the treatment group might be because even if there wasn't that treatment, things would have evolved over time anyway, right? So sales might have just increased over time, for example. Then that difference is two things. It's the treatment effect and it's time. So because it's those two things together, it's going to be hard to say anything about getting that treatment effect separately from time, because treatment turns on with time. So then you could say, well, okay, Lachlan, time's okay. Time and treatment, think of it as two variables. Why can't I just run a linear regression with two variables, treatment and time? In general, it's not going to work, because treatment and time are perfectly correlated in a way, right? As time progressed, treatment turned on. So after the treatment intervention happened, which means that an observation is either going to be before the treatment happened, and that guy's untreated at that point in time, or it's going to be in the after period, and in the after period, he's always treated. So it's going to be very hard. So basically you can't, I think not even, it's going to be very hard. It's going to be impossible to say anything here. Because if you control for time in a regression, for example, you're comparing people with the same values of time. Intuitively, that's what regression does. If you control for time, if you look at the coefficient on treatment, you'd be saying, for people with similar values or the same values of time, how does treatment move around? Treatment doesn't move around, because in the after period, you're always treated, and in the before period, you're always untreated. So it can't work. So we cannot just look at differences in after a treatment happens and before a treatment happens for only the treated group who got the intervention. Won't work. Second proposal might be, okay, what if instead I had observations, which I do have, and I compare people who got the treatment to people who didn't get the treatment in the period after the treatment had already been introduced. Because the untreated guys are untreated in the after period, and the treated guys are treated in the after period. Maybe we can find the difference in those two averages and compute the difference. So that's my second proposed estimator, comparing treated versus untreated in the after period. So we could say a proposed treatment effect is the average of the outcome variable of the treated people in the after period minus the average of the outcome variable in the untreated guys in the after period. Again, this is not going to work. Reasoning slightly different. The treatment group, for some reason, even though you tried to be random in terms of who you allocated to the treatment group, might have just differences in natural variation from the control group. So then any difference in the outcome variable for the treated guys and the untreated guys might be due to the intervention, that treatment, or it could be just due to that natural variation between the two groups of people that you tried to avoid with randomization, but couldn't perfectly do. So then that difference is the sum of the marketing intervention and any of those kind of uncontrolled differences. So this kind of difference in two averages also won't So both of these previous estimates, proposal 1 and proposal 2, didn't work, and they took one difference. There was one minus sign in the averages, in that kind of taking difference in averages. Estimator 1 didn't work because the effect of the intervention, or what we're going to think of as the treatment effect, was confounded, so mixed up with changes over time. Estimator 2 didn't work because the effect of the intervention was confounded by, so muddled up, mixed together with, potential differences between the treated and untreated groups that, although we tried really hard to eradicate via randomization, we may not have been perfectly good at. Difference in differences, which is an idea that is going to work, is going to combine ideas from both of these two proposed estimators that didn't work.